So please go to page 6 of your project. And we've got a little bit of reading and highlighting to do. The chart below gives you enough information to fill in the blanks and to draw the atom. When it said chart, it's not really a chart. The bullets right here give you the information you need to fill in these blanks. You will need to know a little bit more about electron shells to succeed. Again, electron shells are also called orbitals and energy levels. Which has more energy, an electron orbiting close to the nucleus or an electron orbiting further away? Further away has more energy. So the energy levels increase as the atoms get bigger. We add more electrons. The energy levels, or shells, follow a specific pattern. Always add electrons to the inside shell first. When that shell is full, you make another layer, and you start adding electrons to that new shell. If you need to add even more electrons, you might have to add yet another orbital, another shell. And this is the pattern that you follow. The inner shell can only hold 2 electrons. So if there are more than 2 electrons, you have to add more layers, The next shell out can only hold 8. So anything, let's see, what's 2 plus 8? 10. Any atom that has fewer than 10 electrons will only have 2 shells, But if it has more than 10 electrons, you're going to have to add more shells. The third shell also holds 8. Once you've filled up that shell, you go to a 4th layer. It can hold as many as 18. And the 5th layer also holds 18. If you have a really big atom, you might have 6th and 7th orbitals that can hold as many as 32 electrons each. Then another part of this chart down here asks about valence electrons. These are the electrons found on the outside shell, right? We just talked about that. So a valence electron is the number of electrons on the outer shell. Which of these is the outer shell? Any of them could be the outer shell depending on the size of the atom, right? Even this inside shell is the outside shell for the smallest of atoms. For hydrogen and helium, there's only one shell. It's both the inside and the outside, isn't it? So the valence electrons are the ones on the outer shell, and different atoms have different numbers of valence electrons, as well as different numbers of shells. These valence electrons will be important because they determine how the element will react and bond with other elements to make compounds. We're going to talk more about valence electrons later, but they become really important in figuring out the behavior of an atom and its properties. So we're going to move on and fill in this chart. And I'll do the first one for lithium with you. Now, they've given us everything we need to know in this chart to be able to do the whole thing. So they've told me that there are how many protons and how many neutrons? Right. So if they've told me that, can I figure out my number of total electrons? Because the number of total electrons is the same as the number of protons, There we go. Now, I would advise you to fill in the number of shells next and the valence electrons last. So how many shells do we have here? If there's 3 electrons, how many can go on the inside shell? 2 of them, which leaves 1 more, So how many shells do I have? I have 2 layers, don't I? I have 2 orbitals. Now, I already figured this out, actually. If I have the first shell, took 2 of them, that left 1 more electron on the outside. How many valence electrons are there? Well, the outer one is the valence electron, isn't it? With me? So my number of valence electrons is this one electron out here. Now, because this is a pretty small space, we're not going to draw the individual protons and neutrons. Instead, we're just going to write down how many there are in the nucleus. So let me see. I'm going to go 3 protons and 4 neutrons. Personally, I like to draw those inside of a solid circle to show that they're together in the nucleus. Then I like to show the electrons with a dotted circle. And I'm going to need 2 layers of electrons. And I think we did this just yesterday. Didn't I show you how to change a regular circle into a dotted circle? Right click on it, hit the properties, wait for a second to open up, go to style, change it to a dotted line. That's my inside shell. And for me, the easiest thing to do is just copy paste. So I'm going to hold the control button, letter C, hold control, letter V, and then I'm going to make it bigger because it has to go on the outside. I'm going to drag it over to where it belongs. There's my electron shells. I still have to draw the electrons though, don't I? And the way I like to do that is with a fat pencil. So I click on my pencil, I go over here to this icon to change the size of it. It's a 1. I need it to be at 5. Now it's ready. I just click for 1 electron, 2 electrons, and then on the outside shell, 1 more electron. And I'm done with lithium. Okay, so we're going to take the next, I don't know, 15 minutes or so for you to draw the other ones. The remaining 5. Sodium is the biggest one that there is on there. So in a way, it's a little more complicated. I might do, why don't we work our way down the table instead of across? So why don't you guys go to boron? That's one we just did, isn't it? Why don't you go to boron next? What? There's a Pena? So this one told you the number of electrons and neutrons. How many protons must there be? It's the same as the electrons, right? And then figure out the number of shells. And lastly, figure out the number of valence electrons, the VE part. So we did a bunch of practice to begin with, okay? And then we started this page. So you haven't missed too much except for the practice, and we read this together. So let's look at this. So you know the electrons are found in these different layers called shells, right? And different layers can hold different numbers of electrons. The inside shell is full once you get to 2. Then you have to start adding electrons in a shell outside of that. But it can only hold 8. The second one can only hold 8. So once you get 8 in that one, you have to add another layer. And once you get 8 in that one, you have to add another layer, right? But it can hold 18. So they keep getting bigger and bigger, okay? Then there's some new vocabulary. Valence electrons, or VE. And that is a simple thing. It's just the number of electrons in the outside shell. And this controls the way that the atom behaves, controls the characteristics of the atom, the properties, whether it reacts with other elements, which elements it reacts with, stuff like that. Okay, so let's do lithium together. What is this, protons here? Yeah. And it gave us that was 3?
Yeah.
And then neutrons gave us that was 4, correct? Yeah. Then was electrons, is that right?
Electrons, yeah.
Now electrons, how many electrons do you know?
For lithium?
Yeah. It's the same as the protons. Electrons and protons are always the same. Easy enough? Go ahead.
Oh.
Okay. Now, I wish they'd done these in the opposite order. So I want you to do them in the opposite order, okay?
Okay.
So we're going to figure out the number of shells first. How many electrons were there? 3. How many can go on the inside shell? Only 2, which leaves how many left over? Which goes on the next shell out. Now are we done? Wait, that takes care of all 3 electrons, doesn't it?
But don't we also do the protons?
No, just the electrons.
Okay, just the electrons.
Because the protons are packed together in the nucleus.
Oh, yeah.
So there's 2 on the inside shell.
And then 1 on the outside.
And we're only talking about electrons. So we're done. There's only 2 layers. So there's 2 shells. And how many were on the outside shell? Fill up the inside shell first with the first 2.
On the outside
Only 1. That's our valence electrons.
So that's the second for the valence?
Yes. It's how many on the outside?
Okay.
So then, this is the way I drew the atom. We were just practicing actually drawing all the protons and neutrons, but because this is a small space, we just wrote them instead.
Okay.
Is that right? 3 protons and 4 neutrons together in the nucleus. And then 2 electrons on the inside shell, 1 electron on the outside shell.
Wait, how do you know, like, how many protons or neutrons? Oh, wait, because we got out that. Yeah.
If you look at these, they always give you enough to figure that out.
Okay.
Remember, if it only gives you electrons, it's the same as the protons, right? Okay? So I think, go ahead and do your diagram of lithium, and then do boron next. Don't go to sodium yet, because it's a little trickier. Okay? How are we doing out there? Just 2. Show me what you did for sodium. 8 and 1. 2, 8 and 1. Working from the inside out for sodium. Say it. Nice periodic table. You see the box at the top? These are the ones I want you to memorize. And so I'm going to give you some, I'm going to have you make flashcard diagrams. So like the first one's H. We put H on the front and hydrogen on the back. Okay. What I want you to do though is I want you to cut these into 4 pieces each, smaller. And this work down here, when you're done with those 20, the last use of I would do, I will tell you that sodium has one other extra little trick. And hydrogen and helium are sometimes confusing to people, even though they're very simple. Sodium. Looks like you're doing it right to me. So, boron is the next one. And we know that it has 6 neutrons and 5 electrons. Now, the electrons are the same as the protons. So whatever it says for electrons, just put that in for protons. Good. Now, I think you should do this one next. Always do shells before valence. How many total electrons does it have? Total? Yeah, so look, there's 5 electrons. Can they all fit on the inside shell? No, how many can go on the inside? Just 2, so I'm going to take these 2 away on the inside. What's that leave on the outside? Does that make 5? So how many layers do I have? Yeah, so 2 shells at the bottom of that section, 2 shells. And how many went on the outside? How many electrons on the outside? These 3. Those are the valence electrons, the VE. So 3 valence electrons. I'll check sodium because that's probably the tricky one. If you're doing that one, you should be good. You want to look at hydrogen or did you do hydrogen? I think I did. Yeah, you did. You're doing sodium. It's all right. I would do this one next. This one's a little tricky, so let's practice with the easier ones first. Okay? So, what does it tell me? There's 6 neutrons and 5 electrons. How many protons would there be then? Yeah, it's the same as the electrons, isn't it? Okay. Now I think you should jump down to this where it says shells and skip VE until after each. So how many electrons total? 5, right? How many can go on the inside shell? See? 5. Remember up here at the top it said the inside shell can only hold 2. So I'm going to take 2 of them away and put them on the inside shell. How many does that leave on the outside? How many shells do I have? I have 5 electrons, but there's 2 on the inside, 3 on the outside, which makes how many layers? Only 2 layers. And how many valence electrons? The ones on the outside, 3 on the outside. So how many shells was it? 2, yeah, valence electrons 3. Now you should be able to draw that. How many neutrons in hydrogen? The only element. Let me know if you have any questions at home about how to fill these in. You want more? for the extra credit was? Oh, you made them all right. Yeah, these are the ones that are going to be required. Here's for the extra credit ones. You already know. Some of them. Hydrogen. Only one shell, and how many electrons in that one shell? Only one. So how many valence electrons must there be? Only one. Kind of a weird one, though. Boron looks good. Oh, wait, did I already look something? So, are you done all that? Good. Save. You done with scissors, Aussie? All right, go to the next page. There's a periodic table. In this box, these are the elements that how much do you memorize? Cut these into four. And on each mini flashcard, you put the element symbol on one side and the name on the other. Okay. And then there's also a credit, further on the left if you want to do those ones looking more like human parts. Yes. Yeah. Right. Okay. Let me give you a couple of hints at home for these guys. So boron should be pretty easy. It should look very much like the one we just did for lithium, except the outside shell has more electrons in it. And the same thing is true for carbon. Those guys all look very similar. Sodium is going to be a little different because it has so many electrons, we actually have to add a third shell. So if you've done that for sodium, then you're on the right track. It should have 3 shells. Both the inside and the middle shell are filled up according to this bulleted list at the top of the page. The inside shell can only hold 2 electrons. The second shell only holds 8. Add those together, you get 10. But we can see that sodium has 11 electrons, so you have to add a third shell for that extra electron. On the other hand, the last two diagrams are of very small atoms, the two smallest atoms, hydrogen and helium. And you can see hydrogen only has one proton. Helium only has two electrons. That means for each of them, they're only going to have one layer of electrons. Helium filled up that first shell, but hydrogen didn't even fill it. And that means they don't need a second shell. So they look a little different. So if you're doing that, you're on the right track. If you're not, ask me for help. And I want to tell you what you're going to do after this. So let's scroll down to the next page. In fact, can I get everybody's attention up here for a second? When you're done with these diagrams, we're going to go to this next page, which you can see is a colorful periodic table. But I want to draw your attention to this box right here. Here are the symbols of 20 elements, and I want you to memorize the name and symbols of these 20. Like H is for hydrogen, like that. So you're going to make some flashcards. I'm going to give you some index cards to make flashcards for these 20 elements. On one side of the flashcard, you put the letter H. On the back, you put hydrogen. And when you quiz yourself, you should go both directions. Sometimes look at the symbol and give the full name. Sometimes look at the full name and give the symbol for these 20. If you want, there's also some extra credit ones that I listed down here on the bottom left of the periodic table. Some bonus ones. So we're going to make physical flashcards, but I've also made a Quizlet for you. There is now a join code on Teams, and you can also study these guys on the Quizlet. It includes the extra credit ones as well as the required ones. So, first thing to do is finish up page 6 with the diagrams that you've been working on. Save your work, move on to page 7, and if you're in the room, get the index cards from me and make these flashcards. I think just the process of making them helps you to learn it in the first place. And then you have your choice to either quiz yourself with the flashcards or with the Quizlets and the different games that are on Quizlet. You probably know about those already. Okay? So that's how we're going to spend most of the rest of the period.